All right, and we're back. This is section 9.3 video. Let's start with the warm-up. All right, go ahead and pause if you're watching along at home, following along at home. Code word is, did we have anybody out today? Nobody out today. I didn't have anybody out in my secondary class either. So the code word is nothing. There is no code. So 3x squared minus 6x plus 8. This is a warm-up. If you're watching along at home, please pause and do this problem and then check it as we go. All right, what's my formula? Let's do this again. What's my formula for axis of symmetry? Elliot! You don't know that. You didn't know that. Peyton, what's my formula for axis of symmetry? X equals?
Negative b divided by 2a.
Good. Negative b over 2a. Kira, what is it?
Negative b over 2a.
Good. Jake, what is it? X equals?
I actually forgot about it. X equals negative b over 2a.
Sky, what is it?
Negative b over 2a.
X equals negative b over 2a. One more time, Nate. Vader, what is it? Good. Now, Paige, what is A and B here in this case?
A is 3 and b is negative 6.
Good. A is 3, B is negative 6. Do we need to identify what the C value is? No, not right now. We'll do that today, though. So X equals negative B over 2A. Now, I would strongly encourage you not to put the B tucked up with, not to put the negative tucked up in with the B. Don't do that. That's throwing a lot of people off. I would rather you write out the fraction, reduce the fraction, and then see what happens at the end. Okay? So that means I've got negative B over 2 times A. Now, I'm having a lot of people put this in their calculator wrong. Okay? Here's what I need you to do in your calculator. I need you to write, okay, negative, that's the negative sitting out front. And then we can write a negative 6. You can put the double negative 6. Hold on. Hi, Mrs. Hudak. He did. Yep. In between second and second and third. Yeah. Yeah, he came up in 5. Yep. Bye-bye. All right, so we got negative and then a negative 6 divided by. Now, I'm having a lot of people just plug in 2 times 3. You have to put that in parentheses in the bottom. Okay? You got to do 2 times 3 chunked together in a parenthesis. That'll give you what you want. X equals 1. But really, you can just work it out here. Negative, and we'll have a negative 6 over 6. Those will cancel. 1. Now, what did I actually just find? The x value, which is also the axis of symmetry, right? That's the axis of symmetry. I know I could go to the right 1 unit, make my dotted line down, and that would be the center line of the graph. Well, to find my y value, I really just want to plug in that x value. So I would go into my calculator and type in 3 times 1 squared minus 6 times 1 plus 8. Plus 8. I got 5. Y equals 5. That means my coordinate for the vertex is 1, 5. Questions about that? All right, take out your homework. We're going to go through some answers here. Oh, also, I'm getting a lot of people submitting late homework assignments with no work. Now, understand that if I look at your assignment and there is no work shown, I'm not going to give it like half credit. I'm going to give it 0 credit. I'm not going to give you any points. You need to show work. I have some people still submitting these from last chapter, and it's like just answers. And we know from all that factoring stuff, you can't submit into just answers. That doesn't work very well. So I need you to submit work. Okay, I need you to submit work. If you submitted something and it turned out to be a 0, I comment every time. If I put no work shown, if I give you another 0 for it. Okay. All right. What did you get for Brendan? What did you get for number 1?
Negative 1
0 and negative 6, 0.
Good. Now they're showing it here with just the x values. Really it's fine to just give the x values, but I like to give the full coordinate. So negative 6, 0, negative 1, 0. What did we get? Number 2. Drew, what did you get for 2? None at all. Good. Number 3, Morgan?
5, 0.
Just 5, 0. Good. Now we're switching gears to the axis of symmetry. Gavin, what'd you get for number 4?
X equals 3.5.
Good. They write it as 7/2, but 3.5 is just as acceptable there. Dane, what'd you get for 5? X equals 3. Very good. Number 6, Owen? X equals -1. Good. Number 7, Reagan? X equals 1. Yeah, now we're starting to do it with the equation. Kaylee, what'd you get for 8? X equals +2. Very good. Number 9. Give a number. Addie.
X equals, wait, 10?
9.
Oh, X equals -1/16.
-1/16, or if you had -0.0625, that would have been fine as well. 0.0625 is 1/16, so -0.0625. And now for numbers 10, 11, and 12, I need a full coordinate. Taylor, what did you get for 11? Or sorry, number 10? 1, -5. Very good. Emily, what did you get for 11? Oh, good. -2, -22. It seems like really big numbers, but nope, that is the correct answer. And then, come on now. Can I volunteer up for number 12? Yep.
-1, -36.
Very good. -1, -36. Don't be scared of these numbers. All right, questions on any parts of the homework? Anything? Now, you guys will be excited to see there is another worksheet for homework tonight. There's another worksheet for homework tonight. I don't know, 'cause my other class is happy to see another worksheet. Not both of you, I don't know. You gotta do it. What we're gonna do today in class, now the guided notes look very similar to a worksheet. They don't look like our standard guided notes. Reason being is I like these problems on this worksheet, and they're gonna, fit right along with what we would do in a guided notes anyway. So we're using this worksheet as our guided notes for section 9.3. Notice that this says 9.3 practice A. Your worksheet tonight is 9.3 practice B. And tomorrow night's homework, worksheet 9.3 practice
C.
Just kidding, D. That's so silly. It's practice D, not practice C. So this is not your homework, this is a guided note. Well, I don't know sometimes because you usually just texting somebody. True? I don't know. More than like 15 All right. So this is your guided notes. Okay, this is your guided notes. We're not really learning. I guess we're going to learn one new thing today, and it's going to be right here at the beginning. We're going to learn one new thing. Remember when I had said, please don't work ahead. Please listen to me when I'm talking. The one new thing that we are going to learn today is our C value. Now, remember when I said the C value wasn't really important yet? Hiram, here, 0. You got a spot? Yeah. There you go.
Thank you.
You're welcome. See you next period. All right. Yeah. So remember when I said the C value was not really important just quite yet? Now it's going to be important. That C value is going to be extremely important. Now, the C value, where is the C value located? It's the last number, right? The last number. Think back to the last number out of all linear, no, notice these are not quadratics, right? These are just linear functions. Take a look up here on the whiteboard. What was the last number for linear equations? Like, what is this for? The y-intercept, right? Y equals mx plus b. Isn't this the y-intercept? So the y-intercept of this graph is 4. The y-intercept graph of this graph, the y-intercept is -7. What's the y-intercept here?
3.
Positive 3, right? So the y-intercept for linear functions was always the last number. Guess what? It's not going to change for quadratics. What's the y-intercept here?
4.
What's the y-intercept here?
7.
What's the y-intercept here?
3.
Now remember that to calculate the y-intercept, all you need to do is plug in 0 for x. Because you're looking at where it's going to cross the y-axis. And where it's going to cross the y-axis, it's not going to have any left or right. It's going to have 0 left or right. 0 for the x value. Look what happens. 0 plus 3 times 0 is 0. 0 plus 0 is 0 plus 4, 4. Same thing here. This will be a 0. This will be a 0 minus 7. 0 comma negative 7. This would be a 0. This would be a 0 plus 3 is 3. So my last value, that C term that we were talking about that we weren't really using just quite yet, is going to be what our y-intercept is going to be. Okay? So take a look here. Recall that the y-intercept is a y-coordinate of the point where the graph crosses the y, that vertical axis. The coordinate of this graph is always, the x-coordinate is always 0, and the y-coordinate is going to be where it crosses. Okay? The y-coordinate is always going to be that C value, that last term. Take a look at these 3 examples real quick. This is not on your notes or anything. Take a look up here. The C value, the last number, the constant term is -2. It crosses at -2. The constant term is +4, crosses at +4. The constant term is -3, crosses at -3. Okay? Now, I'd like you to flip over your page to the blank back, and I'd like us to write out these steps to graphing a parabola. Leave room, because I'm going to make notes for each part. So to graph a parabola, to graph a parabola, you start by finding the axis of symmetry. Finding the axis of symmetry. Second step, find the vertex. Again, leave room. We're going to separate these numbers out a little bit because I'm going to put some notes in between each one. That's what I said at the beginning. Space this out. Now, we know how to do everything on this list. We have learned how to do everything on this list. What we're doing now is taking everything that we learned from sections 9.1 and 9.2 and compiling everything and now graphing from scratch, given an equation. This is always given an equation. Given an equation, this is how we graph it. So let's first start off by talking about the axis of symmetry. Now, the axis of symmetry is that line running down the center of the graph, right? How do we find, well, what is the equation of the axis of symmetry? X equals negative b over 2a, right? Okay, so let's write that in there. X equals negative b over 2a. Right. When I go to graph the axis of symmetry, I'm going to make a little diagram over here as we go. When I go to find the axis of symmetry, I find that coordinate, or find that x value, and that's where my dotted line is. So say it was like x equals 3 or something like that. I don't know. So I would go to the right 3 units, and I would make a dotted line down vertically at 3. That's the center line of my graph. The next piece is finding the vertex. How do you know, or what do you do to find the vertex? Plug it in. Yeah, you plug it back into the equation. Plug back in. You plug it back in. You go back to the original equation and you plug in your x value. Now, you know that, okay, so say it was like 3 comma negative 4. You know that vertex exists somewhere on that dotted line, right? Now, we've learned about our y-intercept. Where do you find your y-intercept again? The last term. It's your c value, right? It's the last term. The last number. The last term. The constant on the end. Okay, I'll plot it up here. So maybe it's like positive 3 or positive 2 or something like that. I don't know. I'm just making this up as we go. That would be your y-intercept. Your y-intercept, not your x-intercept. Your y-intercept. Now, this is where it gets a little trickier. You find 2 more points on the same side of the axis of symmetry as the point containing the y-intercept. You find 2 more additional points to fill out one side of the graph. Let me ask you this. Everybody, eyes up here on the TV real quick. Eyes up here. Thank you. Now, you see your axis of symmetry. What side of your axis of symmetry is the y-intercept on? It's on the left side, right? If I'm standing there on my axis of symmetry, I have to look to the left to see my y-intercept. So that means I'm going to fill in the rest of my left side. That's what this is saying. Find 2 more points on the same side of the axis of symmetry as the y-intercept. So if it's on the left side, if I'm on my axis of symmetry and I'm looking to the left to find my y-intercept, I've got to pick 2 more points to the left. So that means I'm gonna basically make a table of values, a small table of values. So go ahead and write in an empty table of values. I'm going to pick out a small table of values of 2 more coordinates. 2 more coordinates here and here. That is going to fill out my left side. It's going to fill out my left side. So it's going to look something like this. You know, I'll put it in green, sure. Here and here. It's going to fill out the full left side of the graph. Now, why are we only filling out one side of the graph? Yeah, because the axis of symmetry says, well, whatever's happening on one side, it's going to be a mirror image on the other side. So what I can do in the end with step 5 is reflect everything over to the other side. And then fill in. So in the end, you should have on your graph 2, 4, 6, 7 coordinates on your graph. The vertex, the 2 additional points, the y-intercept, and then those 3 other ones reflected over, giving you 7 total. 7 total. Because your vertex obviously doesn't get reflected. Now, what's nice is, now flip your page back over. What's nice is on your quizzes and tests, I will give you answer blanks like this. I will lead, you don't have to memorize all those steps because I will lead you in that direction. I will tell you, okay, this is what you want to do next, this is what you want to do next, this is what you want to do next. So let's go for it. Let's graph. See, what I'm doing is I'm given the equation, graph the parabola. Given the equation, graph the parabola. First step, find the axis of symmetry. Well, to do so, I need to identify what my A, B, and C values are. Yeah, now I'm taking it one step further to find A, B, and C. What's my A value? B? C? All right, so I've got 1, 2, and -3. Let's first start off by finding my axis of symmetry. X equals -b over 2a. So I have -2 over 2 times 1. Right, -b over 2a. All right, so that's like -2 over 2, or just -1. X equals -1. Everybody look down at your paper. Did you write x equals? If you didn't write x equals -1, I'll take off a point. Make sure you write x equals -1. So now what I'm going to do is I'm going to go ahead and draw that in my graph. I go over to -1. I'm going to draw in that dotted line. I know my vertex exists somewhere on that line. Let's figure out where it is. How do I do that? Plug it in. Y equals -1 squared plus 2 times -1 plus, -3. Okay, so we do parentheses, -1 squared plus 2 times -1 -3. -4. So this is -1 comma -4. So I can go now and say, okay, my coordinate of the vertex, it should exist on that dotted line, and it's at -4 on that dotted line. Now, let me ask you this question. Should this parabola open upward or downward? How do we know? Ooh. A is not negative, A is positive. A is positive. The first term is positive. That's why it opens up. Not down, but up. What's the y-intercept? The reason I ask that is because now the C value, -3, now you could just write -3, but I'm going to write the full coordinate, 0, -3, because now I see that it will indeed open up. It's giving me just that little picture of, okay, there's that bottom point, and now the y-intercept is above it. Now, let me ask you this. I got to fill in my table now. This is a little bit of a tricky part here. My students last period were kind of having some issues with this. Everybody eyes up on the screen here. Well, I'll come over here and do it. Everybody look at me here. Take a look at your dotted line. If I'm looking at my my axis of symmetry, on what side of my axis of symmetry is the y-intercept? It's on the right side, correct? So I've got to pick 2 more points to fill out this full right side so that I can reflect it over. Now, what points am I going to pick? Well, what's my axis of symmetry is at -1. What's the first number to the right of -1? 0. Do I already have a coordinate at 0? Yeah, so don't pick that. What's the next number to the right of 0? What's the next number to the right of 1? So those are the 2 x values that I'm going to pick. If the axis of symmetry was on the other side of the graph, which is what we'll look at next. If it's on the other side of the graph, well, then I'd be picking more points to fill out the left side. Then I have to keep going 2 more coordinates. I don't know actually if it's the next one, but maybe the left. Okay. So let's just figure out those 2 coordinates. Run the numbers. Plug it back into the formula. We've got 1 squared plus 2 times 1 -3. 0. And then I do 2. 2 squared plus 2 times 2 -3. 5. So my 2 other points, 1, 0, 2, 5. that will like finish off the rest of the image on the right side. 1, 0, 2, 5. Do you see how I have a full right side of the parabola now? I see everything that exists on my right side, so now all I need to do is just reflect it, mirror image over onto the left side. Let's do that. I'm going to show these points in green here. So look, here's 1 unit away from the axis here, so 1 unit here. 2 units here, so 2 units on the other side. 3 units away here, so 3 units away on the other side. 1, 2, 3. Mirror image, right? It's a mirror image on the other side of the axis, on the other side of axis of symmetry. You see how I construct those 3 green points? I look vertically, I say, okay, it's 1 unit away from the dotted line here, 1 unit away from here. 2 units away from the dotted line here, 2 units away from the dotted line here. 3 units away from the dotted line here, 3 units away from the dotted line there. And now I connect my dots. Questions about that? Let's repeat that process. Let's do that again. Let me ask you this question first off the bat. Let everybody look at number 2. Should that one open upward or downward?
Downward.
Downward. Okay. I know right away that this should open downward. I don't even ask you that because you should just know that from here on. That's kind of like a quick check to see, okay, does it open upward or downward? How do we know that? Again, the negative in the very beginning shows that it's opening downward. All right, so let's get to it. Let's identify A, B, and C. What's the A value?
-2.
B value?
-8.
C?
10.
Let's go into our axis of symmetry. X equals negative B over 2A. So we've got negative. Watch out here. I've got 3 negatives going on. Negative, -8, 2 times -4. Oh, sorry, 2 times -2. Watch out. 3 negatives going on. Okay, so here. This gets me a negative, -8, over -4. 2 of them will cancel out. 1 of them will be left over. So my final axis of symmetry is x equals -2. I don't care which ones you think about canceling. I like to think about it like this. Top to bottom, those negatives will cancel, leaving the 1 left on the outside. -2. So my axis of symmetry is at x equals -2. And now, I guess this one's axis is on the left side as well. I'm going to make my dotted line here at -2. That's the center line. You know, once you get your axis of symmetry, you can go right away into the next blank and write -2 comma something. Because we know that x value should match the x coordinate of the axis of symmetry, or the x coordinate of the vertex. Okay, to find the y value, what am I going to do? Plug it in. -2 times -2 squared, -8 times -2, plus 10. I'd like everybody to plug this into their calculators for me, because I would hate for you to miss points because you're not plugging it into your calculator correctly. So go ahead and do it, and make sure we get all the same answer. Here's how it should look. -2 times -2 squared, -8 times -2, plus 10. 18 you should have gotten. -2 comma 18. All right, so there's my vertex. Yes.
I got -118.
That's what I understand.
The negative side is not the same as the minus side. Now. I was thinking, I was like, you were, wait, you were thinking?
I was like, it should be -8, but it shouldn't.
-8.
That's pretty close. I'll give it to you.
All right, now, you may be thinking to yourself, whoa, that vertex is really high up there. I'm not going to see my graph. Oh, wait, that's right. It points downward, not upward. All right, where's the y-intercept? 10. 0, comma 10. Question. Oh, yeah, sure. 0, comma 10. Okay. All right, now I got to make my table. Now I got to do this tricky part where I figure out what 2 other points I want. Now, everybody take a look here. I need everybody eyes up here. Where is my axis of symmetry? Where is my axis of symmetry? -2. Where's my y-intercept? On the right. So I'm going to pick 2 more points on the right side. What's my next coordinate to the right of -2? -1. What's my next coordinate to the right of -1? To the right. 0. Am I going to pick 0 in my table? No, because I just found that coordinate. So what's the next coordinate to the right of 0? Okay, that's how we choose those coordinates. That's how we choose those 2 values. You figure out which side your axis of symmetry is on in terms of your y-intercept, and you keep making points on that side. Okay, let's run it in. Run it in the formula. -2 times -1 squared -8 times -1 minus 8 times -1 plus 10. 16. Do you use a minus sign or a negative sign?
The minus sign.
I don't know what you're doing. We got -2 times just a 1 squared minus 8 times 1 plus 10. 0. So my 2 coordinates are negative, did I write it out? Yeah. -1 comma 16, 1 comma 0. So I have -1 comma 16, 1 comma 0. So do you see I have the full right side? Of the full right side of the parabola? Mirror image over to the other side. 1 unit away here, 1 unit away here, 2 units away here, 2 units away here, 3 units away here, 3 units away there. And I can fill in, I can connect my dots. Questions about that? Again, when you do the mirror image, it should be on the same vertical plane, right? So like, I'm looking here, the mirror image of this point here is 3 units away here. It's got to be 3 units away over from the other side as well. The line of reflection is the same distance to the inside. All right, let's take a look at the last problem, the word problem. Now, I could have asked you this problem yesterday. We're going to keep continuing on, bringing in new real-life examples of quadratic functions. Like, for example, remember yesterday I was throwing that ball in the air, given a curved shape, right? The rainbow shape, right? That is a quadratic. Now, taking a look at this one. A dolphin jumps out of the water. It comes back down. That is, again, a quadratic, a parabola. What is this -6 or -16 telling you? It's going downward. The shape of the graph is going downward, which makes sense. Dolphin jumps out of the water, comes back down. Now, I want to know what the maximum height is. What coordinate am I really asking you for when I ask for the maximum? The vertex, right. I'm going to find the vertex. Find the vertex of the parabola. Well, we know how to do that. The first thing that we got to do is find the axis of symmetry. -b over 2a. What's my a value? B?
32.
What's my c value? 0. All right, let's plug it in I've got negative 16 over 2 times, negative 32. I put on A on top. Whoops. Negative 32 over 2 times negative 16. That's a lot. Positive on top. All right, now, let's run the number here. I've got negative 32 over negative 32. Those will cancel, being a positive 1. Positive 1. So I'm going to go here. I know my axis of symmetry. Positive 1. Is that my maximum height? No. It didn't go 1 foot in the air. That wouldn't make sense. The y value is my maximum. Negative 16 times 1 squared plus 32 times 1. Well, that's pretty easy to compute. That's just negative 16 plus 32, or 16. 1 comma 16 is our vertex. What's the maximum height? 16 feet. How long did it take to reach the maximum height? 1 second. 1 second. Guys, all of your answers for these problems are going to be reasonable. I'm never going to give you a problem that's going to be unreasonable. Because I had, you might have tried to tell me, 16 seconds. Oh, really? A dolphin's going to be in the air for 16 seconds? Just to reach the top height? 1, 2, 3, 4, 5, 6, 7, 8, halfway there, 9, 10, 11, 12, 13, 14, 15. And that's when it reaches its maximum height? Holy chicken nuggets, that's a supersonic dolphin. 1 second. Now let me ask you this. Hold on, we're not done. What's the total time in air? 2 seconds. How do you know that for sure? Right. However much time it takes to get to the top, that's the exact amount of time it always takes to get to the bottom. Anything you throw, ball you kick, whatever, anything you throw, the exact time it takes to get to the top is the exact time it takes to get to the bottom. Here's your worksheet.